Alright, well, hello everyone. As you guys can see, this is going to be the review for Chapter 2's test. The test is going to be tomorrow. Even though I'm not here, we're still going to have the test tomorrow. I talked to you about it last week. So the test will be tomorrow. And you can go on YouTube and check this out at home later tonight after you guys get done watching this in class today. So, first question on the review says if p of x equals 3x to the fourth plus 2x squared minus x plus 1, use synthetic substitution to find p of negative 2, p of 1/3, and p of I. Okay, there's three equations there. Synthetic substitution is the same as synthetic division, which I think you all know how to do. So, we'll start it up here. What's the key thing that you have to remember when doing synthetic substitution? Yep, remember those placeholders. So I have an x to the fourth. Notice right here I am missing an x cubed. I don't have an x cubed. Okay, since I don't have an x cubed, I would put a 0 in. My x squared would be a 2. My x is a negative 1. And then I have to put that 1 down for my constant at the end. Okay, when we're doing synthetic substitution, that doesn't mean you're going to get 0. You can get 0, but it doesn't mean it has to give me 0. It'll just give me some number. Okay, so if I do p of negative 2, I would plug in a negative 2 here. And the process here is you drop your number down, and then you multiply to go up. So you multiply and get a negative 6, and then you add these two numbers together going downward, and that gives me negative 6. And I multiply to go up and get a 12, and then I add to get 14, and then I multiply and get negative 28, and then I add and get negative 29, and then I multiply 29 times 2 to get a positive 58, and then I add, and my answer for this problem is 59. So what's p of negative 2 equal? 59. Okay, so that's negative 2. I think you guys know how to do that. So let's do the 1/3 next. Okay, so I'm going to get rid of this. I'm going to get rid of all these guys. Same problem, except now we're going to do 1/3. So you rewrite them again. I have the luxury of not having to rewrite it. So now I'm going to plug in 1/3 into that box. Same rules apply. So I drop down my 3. I multiply, 1/3 of 3 would be 1, and then I add, multiply, add. Well, if you don't know how to do that, guess what you get to do? Take your calculator, and you would type in 2 plus parenthesis 1 divided by 3 parenthesis, and I would hit math, fraction, and that would give me 7/3. Okay, again, then I would multiply. So if you don't know how to multiply that, I would then go times parenthesis 1 divided by 3, close off the parenthesis, and then again I would hit math fraction. When I multiply, I now have 7/9. Okay, and then now I have a negative 1, so you go negative 1 in your calculator, plus 7 divided by 9, and again I hit math fraction, I have negative 2/9. Okay, and then to multiply, again, you multiply it using your calculator if you don't know how to do that. If not, it's just the 1 times the 2, so it would be negative 2 over 27. Okay, and you can do common denominator on this, so if you don't want to do it with your calculator, this would be like 27 over 27. So I'd have 27 27s minus 2 27s gives me 25 27s. And again, if you did that with your calculator and click math fraction, you would get to the same answer. Okay, next answer here is the I. Again, same rules apply. We're just going to make sure we know our rules for when we multiply i's. Okay. So, now with our i's, I'm going to put an I in here. So rule is you drop it down, to go up you multiply. So that gives me 3i. It's like an x. So if you multiply by an x, it's 3x, it's 3i. And then you add 3i plus 0 gives me 3i. And then multiplying, so to go back up now, it's 3 I times I, so 3I times I gives me 3I squared. And what's I squared always turn into? A negative 1. So what does that actually give me there then? A negative 3. Okay? And then you add, and I get a negative 1. And then I multiply to go up, and I get a negative 1I. Now here, when you add that, can you add an x with a whole number? Nope. So then all you do here is you just bring it down, and it would give me negative 1 minus negative 1I. You can't combine them, so you just write it down. Now when you take it and you go back up, again you have to multiply. So if I have negative 1 minus I, and I'm multiplying by this I out in front, you have to distribute. So negative 1 times I gives me negative I. Okay, and then negative, or I times a negative I gives me a negative I squared. Now what does I squared actually turn into again though? Negative 1. And then two negatives here make a positive. So technically, what do I actually have here? I'll bring this whole thing down and I'll rewrite it nicely. I technically have negative I, and then this right here would turn into a plus 1. So now if I added all these, because that's what you do when you go down, 1 plus 1 gives me 2 minus I, and that's my answer. Alright, next question. Two roots of the equation are x to the fourth minus 3x cubed minus 14x squared plus 12x plus 40 equals 0. They gave me two roots. Another name for roots is solution or zeros. So this is an answer, and this is an answer, and it says find the remaining answers, or the remaining roots. How do we do that? We use synthetic division. Okay, again, placeholders if I need them, so on this problem, there are no placeholders so that I'm missing, so therefore I can just put them all down. And again, it doesn't matter what number I put in this box first, I'll go with the 2. Okay, and let's do this process. Now, because it says these are two roots, my answer at the end has to equal 0. They told me they're roots, so it has to. If it doesn't, you did something wrong, you need to go back and check your work. Okay, so you multiply, add, multiply, add, multiply, add, multiply. Ooh, nice. And did it give me 0? Yep. Now it says find the remaining roots. Am I down to 3 terms down here? Am I down to 3 terms down here? No, not yet. Okay, so I need to keep breaking it down. So how do you keep breaking it down? You put another box right there, and now I'm going to put this 5 in there. Okay, don't go back to the beginning or you'll be stuck and you'll never get to the 3 terms and just keep breaking it down into 4. Okay, so I bring my 1 down, I multiply, I add, I multiply, I add, I multiply, and again, because it was a root, it has to equal 0. Now, once I have 3, how do I finish this problem out? I rewrite it as x squared plus 4x plus 4, okay? And then you could try 2 things from this, 3 things, but I can either factor this, or if you guys like quadratic formula, do quadratic. I'm going to factor because factor is quicker and easier on this problem. Quadratic would get me to the same answer though. What times what gives me x squared? X and x. What times what gives me my last term of 4? 2 times 2. I have to get the middle term of positive 4. Guess what? They're both positive. So how do you find the zeros of the function now or the remaining roots? You said each one equal to 0. So x equals negative 2. And technically it equals negative 2 twice. Do I need to write it twice? I don't. Okay, you could just write x equals negative 2 and you'd be done. What are my other answers? 5 and 2. So 2, 5, and then there's a double root negative 2. Guess what's probably going to happen to this double root on a graph at negative 2? It's going to probably bounce, either up or down. Okay? Alright, next problem. Sketch the graph. So now they gave me a graph. You do need to do this on the test. You can use your calculator to check it, but you're going to have to give me the pluses and minuses and a number line on the test tomorrow. Okay, so first step is find the what of the functions, the zero of the function. Okay, so find the zeros. Well, if I set each one equal to 0, this one would equal 0. If I set this equal to 0, I get -1. And if I set this equal to 0, I get 2. What do you guys notice going on right here? A squared? What's a squared going to do for me? That's a double root. What does double roots do? They bounce when you hit a line, so they'll bounce. Okay, so at 2 it should probably be bouncing, so let's check it here. So if I do my number line, I got a 0, I got a -1, I got a 2. You need to fill in the numbers and you have to go put your dots on there too. So 2, 0, -1, and I gotta go one number over farther on this side and one number over to the right. Okay, and now what we're gonna have to do is you're gonna have to do your sign checks. Okay, so to do my sign checks, I check -2 first. So if I try a -2 up here, if I plug in a -2 right here, that should give me a negative value. Okay, if I plug in a -2 to this x, -2 plus 1 would give me a -1. You don't need to worry about that number, just if it's negative or positive. What do squares always turn your numbers into every single time? Squares always make it what? Positive, because a negative times a negative is a positive, and a positive times a positive is a positive. Okay, and when you multiply all three of these together, you'll get a positive, because two negatives make a positive. So therefore, when I plugged in -2 up here, it is positive. Okay? Now it should flow except where the double root is, so it should bounce at 2, so we probably know it's going to flow from up to down, and what's going to happen at the 2? It's going to do what? It's bouncing because it's a double root. Okay, but we got to check it. I can't just go like that and call it good. You have to actually do the checking. So now I would check the next one. What number is in between this spot from here to here? Okay, and the number in between there would be -1/2. So if I plug in a -1/2 up here, I'd have a negative. 1 plus a -1/2 would be a positive. And again, the square is always positive. So if you multiply these together, that gives me a negative. What's in between the next root? So 0 and 2, 1 would be checked. Well, 1 is positive. 1 plus 1 is 2, so that's positive. And this is always positive, so it is positive. And then if I check 3, positive, positive, always positive, and did my signs match up? And you have to have those signs on the test tomorrow. And it did. Alright? Let's try another one here. Okay? So actually, what do you notice about this one compared to this one? Same problem, isn't it? Except what's different? You guys see there's a negative sign right here. So now when I do that, same process. So we already know the zeros. We know that it was at 0, it was at -1, and it was at 2. And again, what's going to happen at 2? There's a what? A double root. Okay, but now this sign that's negative, I'm going to bring that out here. So now when I do this, it's going to be whatever this is, whatever this parenthesis gives me, and whatever this parenthesis gives me. There's going to be 4 signs now, instead of the last problem, where there was just 3. Okay, so then again, I'm going to test, put my dots down here. Okay, and I'm going to test my numbers. So -2, well, I put a negative in for my x here, so -2 would be negative, which technically if you included the negative, these two together give me a positive at the end. If I plug in a -2 here, -2 plus 1 is negative, and then when you square something, it's always positive. Okay, and now I have 3 negatives, which makes a negative. So at -2, we're going to be negative. And again, what should these always do? They always flow except where? Where there is a square, which is called a double root. Okay? So again, I can't just do that, though I have to check it. So if I checked between 0 and -1, I would check a -1/2. Well, -1/2 would be negative here. But then in the next spot here, when I plugged it into here, it's now positive. So 2 negatives make a positive. Again, the square is always positive. Okay, and if I check 1, 1 is positive here. Okay, 1 is positive here, and this is always positive. So therefore, those signs make a negative. And then at 3, again, 3 is positive, 3 is positive, 3 is positive. Those signs together make a negative. And that's my graph. Alright, now it says give the equation, so I'm going to give you a problem tomorrow where you're going to have to tell me what the equation is. Okay, so if I want to find the equation of this, my first step would be I need to find the roots. So how do I find the roots on this graph? Okay, so if I want to find the roots, well, I can see that one's at 0 and one's at 2. So it'd be like x equals 0 and x equals 2. Well, I want to write it as a factored form, so what would x equal 2 turn into as a factored form? If you move the 2 back over, you'd have to do what? Minus it? And if the x is already an x, you see how now there's my equation? Okay, so here's my equation. Now the question is, I just got to check a sign and see if it goes up or down. So I'll check 1. So I'll check 1. At 1, what should my sign be? It should be negative because you see how here it's below the graph. Ooh, what else is happening up here though? I forgot one thing. What's happening at 0 here, right here? It's doing what? It's bouncing, right? So what do I know at 0? Where 0 is, it's a double root, right? Which means, what do I got to put on the x? Squared. Okay, so it should be x squared, because it's a double root, which means squareds are always what? Positive. Okay, so we're testing again this 1, and the sign should be negative because it's below the x-axis. So if I plug in a 1 right here, what's 1 minus 2 give me? Negative 1. So then that's a negative. This was a positive because it's squared. Therefore, what do I know here? This should be negative. So since it's negative here at the end when we equaled it, and it's negative here, this is my actual equation. And how would I write it if I wrote it out? I'd write it like this. Y equals x squared, and then x minus 2. And there's my equation for that graph. Questions on that? Alright, there are 1 or 2 word problems. One might be a bonus, I can't remember. Okay, says if a movie theater is going to get more people to come to the movie, they want to find how much money they can drop their price and make the, key word came up here, max profit. Max. We are looking for maximum sales. Okay? The tickets cost $12. They usually get 200 people every movie production. For every $1 they drop the price, they will gain 20 people. When we're talking about maximums, what does that mean we're going to have as a graph? Like what type of equation? A maximum would be like a peak, right? Or a, what's this called again? This is called a what? Vertex. I need to find the equation of a parabola then. And then probably use what formula? The vertex formula. Okay? So, how do you find the profit? Well, profit is people, right? Times how much money it costs. So however many people you get times the amount of money gives me the total cost. So then on this problem here, if I did that, I start with 200 people. How much does each person cost? So we got 200 people here. And then we got, the tickets cost what? $12. Now what's happening here? For every $1, they what? Drop. So the $1 drop would be a minus $1. Do I know how many times it's going to drop? Nope, so I'm going to put an X there. Okay? They will gain 20 people. How do you do gaining of 20 people? Plus 20. Again, do I know how many gains of that they're going to be? No, so I'm going to put an X. What do I do first here before I got an equation? Yep, let's FOIL. So if I'm going to FOIL here, 200 times 12 would be 24 with 2 zeros. First, outer, so that's 200x. Inner, that would be 12 times 2 would be 24 with a 0, and then an x, and then my last. So this guy and this guy, which gives me a negative 20x squared. Okay, if I'm going to actually do this in the correct process, how would I actually write this out then? Negative 20x squared needs to be in the front. I got to combine my like terms, which gives me a plus 40x, and then a plus 2400. Okay, what's the formula for the vertex here? X equals negative b over 2a. Okay, so x equals negative 40. Remember that's A, B, C. C is my y-intercept always. Negative b over 2a. Alright, so that would give me negative 40 over negative 40, which equals positive 1. Okay, what's the question asked? So one increase. Okay, is what they're doing here. Because that's what we're talking about. So for every increase, you lose $1 and you would gain 20 people. So what's the question asked? What is the best what? Best price. So are they asking my profit or the best price for the movie? Okay, it says best price for the movie. So if x was equal to 1 here, what would I do to find the best price of that movie? I would come up here and I would plug in a what? A 1. 1 times 1 gives me 1, so I'd have 12 minus 1, which, what does 12 minus 1 give me? $11. So $11 would be the best price of the movie to maximize your profit. After that, you'd be losing money. Questions on that? Alright. Next question here. A farmer wants to make a rectangular enclosure using a wall as one side and 80 meters of fencing for the other 3 sides. Okay, so we got a wall and then we got 80 meters of fencing. Fencing would be from here to here to here. So these are the 3 sides of fencing. So the blue equals 80 meters. Okay, well, I have an X here. And I also, if that's X, which other one has to be X? So technically, how many sides of X do I have up here? 2 of them, right? Okay, and if I actually want to find out what the bottom piece is, I'd actually have to get rid of this X, right? And I get rid of this X. And if you get rid of those 2 X's now, I'd be left with the bottom. How many X's did I get rid of? I got rid of 2 X's. So what would be the bottom length then up here if I did that? It would be 80 minus my 2x, because here was 1x and here was the other. If you had another piece of fence in there, then you'd have to subtract 3 x's. Okay? So now I got my sides, and now I got to read the question here. It says find x, the value of x, and then give the maximum area. Maximum, same problem as the last time. Maximum is also called a vertex. Area formula is probably what we need to know here. We got a what shape? Yep, a rectangle. So rectangle area equals length times width. And how do you do length times width? Once we're doing that, then we just distribute. So we have 80x minus 2x squared. Now if it's parabola, I probably should reorder this properly. So it's actually negative 2x squared plus 80x. And we're looking for the maximum. And again, you can always use your calculator and go second calculate the max. It's just hard because you have to move your window around if you do that. Okay, but the other formula, since this is a max, is called a vertex. So if I want to find the vertex, that's x equals negative b over 2a. So x equals negative 80 over 2a. So negative 80 over negative 4. And what is 80 divided by 4? 20. So x equals 20. Okay, so if x equals 20, you can do 2 things to find the area. So the side length here is 20. So you can either plug in a 20 here and then solve it out that way, or I can take this 20 and plug it back into my equation here. So it'd be 80 parenthesis 20. So 80 parenthesis 20, close off the parenthesis, minus 2 parenthesis 20 parentheses squared. And that gave me 800. So 800 meters squared is the area, the best area that I can get for that barn, and x would be the length. And if you did it over here, it'd be 20 times 2 is 40, and then 80 minus 40, so this length would have been 40 by 20. And did your calculator, 20 times 40, That also gives me 800. So you can do it both ways. Question on that. All right, next one. We didn't do this a lot this chapter, but we did it a lot last year, and we've done it before, earlier in the quarter here this year. So using a calculator, list the zero of the function. So we'll do this one together here. So take your calculator out, and we're going to go into y equals. I'm going to go negative, and then go x cubed, so caret 3. And then minus 2x, oops. So minus 2x squared. And then minus 7x. And then plus 2. All right, and let's graph it and see what it looks like. Okay, on this problem, it looks like there's probably 1 0 right here. So how do I find that 0? I go second, calculate, that'd be the trace button up here. The what? The 0. Okay, left bound means to the left of the 0, which means to the left side of where it crosses the x-axis. So on this graph, left of that would be above. So right now, I'd actually be fine right here. I can hit enter. Right bound means I click the right arrow until it goes across the x-axis. So do you see how now I clicked it a couple times and it's across the x-axis? Okay, I would hit enter, and then it says guess, hit enter again. And so this answer would be 0.26. So 0.26. And that's my answer. I might just go zoom here and zoom out. And then once I'm here, hit enter once just to see if there's anything else happening there. And I can hit enter one more time. Oops, hit pause it. If I hit enter one more time, it'll zoom it out again. And there's not really anything else happening, like it's not coming back up. So I'm going to go back to zoom 6, the standard. And now there's only one crossing, or 1 0 of the function. On the test there might be 2. I don't remember again, that's just off my memory. All right, we got 1, 2, 3 problems left. Okay, so solve. First thing whenever it says solve, what's the first thing we need to do? Yep, move everything to the same side. So I'd subtract my 12 over, and I would add my 8x over. Okay, and when I do that, I now have 2x cubed minus 3x squared. I'm going to put these in the correct order, so when I move them over, the plus 8x would be first, and the minus 12 would be at the end, and it equals 0, because these guys canceled on this side. We do one side and do the other. Okay, so there's 0 on this side, so that's why it's equal to 0 on the right. Okay, now if you look up here, how many terms are sitting up there? Correct, 4. So how did we factor with 4 terms? We learned that this chapter, or reviewed it. Correct, factor by grouping. So if I'm going to group them, I'm going to group them in 2s. Okay, what's common in the first set? Well, I see an x squared in common. And then if I did that, it's x squared times 2x would be 2x to the cube. And then a negative 3 there. Okay, now what's common in the second set? What? No x's, but how about number-wise? A 4? Yep, and it's positive 4. So now I'm left with 4 times 2 gives me 8, and 4 times 3 gives me 12. Now, what's really awesome about this, once I did that, has to happen every single time. Common term, right? So what do I do with that common term? I bring it out in front. It's almost like you're factoring again out in front. So common term comes out in front, and the leftovers go in the second parenthesis. Okay? Now, can I factor the leftovers? You'd think so, except is that the difference of 2 squares in the second parenthesis, or the sum? Okay, and that's the sum, so we can't do that. The only ones we can factor is the difference of 2 squares. So how do I solve this or find the roots? Because it says solve, which means I need an answer. Well, I can set them equal to what? Because they're being multiplied, they equal what? 0? So 2x minus 3 equals 0, or x squared plus 4 equals 0. I'll minus the 4 over, I get x squared equaling -4, and then you do what to get rid of a square? Ooh, nice, a square root of a negative, what does that turn into? An I? And what's the square root of 4? 2. So now I got two imaginary numbers, those don't cross the x-axis. And then how do I find the other answer here? Divide by 2. And then I get x equaling 3/2. So this actually has one crossing on my graph. How many answers are here? 3? What was the power to start with? Power of 3.